Hi everyone and welcome. Thank you for joining us today. Joining us for our Twilight talk, our monthly Twilight talks, and today it's introducing Mykor and MykoFoam. In a moment, I will be handing over to Olivia to take you through the presentation. But before I do that, I just want to outline a few housekeeping items. So microphones, if you could just keep your microphones muted if you're not speaking, just so that everyone doesn't pick up background noise and things like that, because it can be quite distracting to everyone. Videos, it's completely up to you whether you have it on or off. Sometimes it's nice for the speakers to be able to see who they're talking to, but as I say, completely up to you. If you've got any questions throughout the presentation, there will actually be a section at the end for people to ask. So if you just wait until the end, and then we'll get to a Q&A session. If you experience any technical issues throughout the session, send me a message in the chat and I will do what I can to help. Sometimes if there's connection issues, turning your camera off can help, but anything more than that, and I will do what I can. After the training, we will be sending out a feedback form for everyone. I know everyone asks for feedback these days, but it is really, really good for us and important to us to know what you enjoyed about a session, what you'd like to see more of, what else we can do. So please do consider filling that out and getting it back to us. We'll also be sending out the presentation and a copy of the video and the chat transcript from the session as well. So thank you very much for your time today, and I will pass you over to Olivia. Take it away.
Thank you, Sarah. And hello, everybody. Good to see so many people. Thank you so much for being with us today. Let me just share my screen. We can get straight into it. Okay, so today we're going to talk about strategies to decarbonize the construction industry. So at Mykor, we are here to create biotechnology, and we are a manufacturing company. So we're developing commercially viable and sustainable building materials made from waste byproducts from industry and from fungi, which I'll go into in more detail. So I am a co-founder of Mykor. My background is in architecture. I trained as an architect in the UK. I think there might be a technical issue here, actually. Sorry, 1 minute.
Are you all right there, Olivia?
Got it. Sorry, it was just frozen. So I'm originally from the UK, but I'm based at the moment in Portugal, and I have been here since 2017. I've got experience working in sustainable architecture projects, including residential construction using hempcrete. I was involved in the development and the execution of the first hempcrete project in Portugal, and I've also developed innovative tiles for companies such as LVMH, and also worked in project management and sustainability assessment and certification in Portugal. So at Mykor, we decarbonize the construction industry by manufacturing carbon negative materials. And so today, we wanted to set these key learning objectives taken from our CPD, which we can offer as a certification, should that be of interest. So what it means to decarbonize the construction industry, what is operational carbon, embodied carbon, and sequestered carbon, and can biomass waste products be the solution, and how the construction industry should adopt a cradle-to-cradle approach. So having in consideration the target of being net zero by 2040, how can we make this change now? And when we think about carbon emissions and how to tackle them, we shouldn't focus on just seeing a number on a technical data sheet, but understanding the holistic system. And that means that we need to understand operational carbon emissions, embodied carbon, and sequestered carbon. And we'll understand these terms a little later on down the line, just to clarify that. And how we can tackle them in a more generic way. And then during this course, we'll also consider the biomass waste materials as a solution and try to understand why and how. So to start off with these terms that I mentioned. So what are some of the problems of the construction industry? We believe that the two critical issues that we need to be addressing in the construction industry is both embodied carbon and operational carbon, because these are divided into represented 50-50 and two. Operational carbon is essentially the energy required to heat, light, and cool our buildings. And then embodied carbon is the energy required to manufacture our products that are put into the fabric of our buildings. So just looking at the facts on a global level, on a European level, we've got 28% of European carbon emissions being represented by operational carbon, and the 11% of global carbon emissions are coming from the embodied carbon of the manufacturing of construction materials. So going a little bit more specific to Mykor, 3% of global carbon emissions are coming from the manufacturing of insulation. And that's where we would like to come in to also step in on the operational carbon, because we're also combating against the use of energy for heating and for cooling. So we can therefore reduce that 28% as well as that 3%. We're very directly tackling essentially 30% of European and global carbon emissions here. So 1 second, sorry. Just recovering from a really horrible chest infection. I think it's really doing its rounds. Hope everyone's feeling well. So in 5 EU countries, Sweden, Denmark, France, and Finland, and the Netherlands, they have already introduced regulation on whole life carbon emissions. Essentially, what this means is that they're addressing both operational and embodied emissions. The UK government is addressing this issue with Part Z amendment to the building regulations, and this is currently being read in the House of Commons at a very early stage. And this is called the Carbon Emissions Buildings Bill. So you can see up here on the right. And you can follow that in the House of Commons. It's currently live online. For buildings over 1,000 meters squared, there's a whole life carbon reporting, which will be required from 2025. And the embodied carbon limits are planned to come into force from 2027. And this is all to achieve the government's roadmap to net zero by 2050. So relating to operational carbon, the future home standard is the improvement made on Part L and H of the buildings regulation, the standards put in place in 2013. And Part L refers to a reduction of 70% of CO2 by 2025 through fuel and power use. So this reduction could be done through reduction of building services such as insulating buildings. So construction materials can be made by biomass. And this is what we're demonstrating at Mykor. They are valuable products. So when we're talking about biomass, we're talking about industrial residues that, in other words, wouldn't be valorized because they're a subproduct, they're a sub-process to their manufacturing process. And in our case, we collaborate with one of the biggest paper manufacturers in Europe. And so they're producing on average about 1 to 2 million tons of cellulosic waste every year. And at the moment they incinerate it. They are using it as a biofuel. However, we believe that there's an extra lease of life and value that could be used with these industrial residues. So they offer, not only are we diverting that carbon from being released, but we're also believing that the biomass can produce high thermal performance, sound insulation and thermal mass, and a superior indoor air quality, and can also prevent or reduce condensation, so regulating moisture. Bio-based materials can sequester more carbon than is embodied in construction, therefore having a negative carbon footprint. Obviously this is declared in an LCA and in an EPD now as a biogenic element, and it's not grouped together. Depending on how the product is then dealt with at the end of its life, this can be considered as a negative product. However, the knowledge of the benefits of hygroscopic properties of these types of bio-based materials may not be universally or properly understood by construction industry professionals. So this is a challenge. What else are challenges to us? There are issues also around finance, knowledge, and policy. So to just go into the finance element, there's definitely a perception, and a fair one, that green building materials are more expensive, and that they come with an increased capital cost in an industry driven by finance. Environmentally certified products generally have premium price points, and then the bio-based materials need to be a profitable option for construction industry professionals to have confidence in their use. There is already in the market profitable solutions, but little knowledge on how to use them is I'd say one of the barriers, and obviously subsidies in making them scalable at a price competitive price point is challenging. Knowledge. The advantages of using bio-based is not as well known. For example, absorption of moisture from the air, and then the renewable supply chain and biogenic carbon sequestration with plant-based material, and the hygroscopic materials absorb and desorb moisture, and otherwise known as moisture buffering, and this attenuates peaks and troughs throughout in humidity, leading to improved indoor environmental quality and potential for improved energy performance. And then also the policy. So policymakers have a key role to play in promoting sustainability in construction. So sustainable construction has been addressed at national and international levels. Government policies have required planning applications to meet carbon targets. For example, in specific councils. A tax on carbon in the construction industry is one option for punitive legislation to promote circularity in construction, and has been adopted in numerous countries. So the aim of reducing carbon emissions inevitably impacts on the operational costs of the construction industry. Bio-based subsidy measures are also in operation, and however, they are mostly focused on biofuels and energy, and there are limited subsidies for bio-based construction materials, and it's mostly limited just to the R&D rather than the actual scale up of these products, which is why we're seeing these issues around the price points. And there could also be effects around the political events and changes in that. So So the construction industry needs to play a significant role in reducing the use of virgin materials, reducing the energy required in processing resources, and furthermore, a reduction in waste resulting from non-recyclable products. So the circular economy in the context of the construction industry represents the aim to construct in a sustainable manner where renewable natural resources are being reused following the design life of the product. And bio-based materials are a great example of this circular construction attitude, and they are renewable and can be recycled, resulting in minimal waste and reducing the demand for resources or materials. Not only this, they can sequester carbon during the lifetime of the building, and from being plant origins, and storing carbon within the building that it's installed. So this in contrast to the linear economy model, which ultimately involves waste product requiring disposal and new increased demand for source material. So LCAs and EPDs are really important to be able to measure and compare with third-party verified data. However, there is little understanding on how to read them. They're also very hard to compare. and they're not. It's not an obligation for a manufacturer to declare every part of the stage process. So sometimes you're comparing a product with data that isn't complete, and that can pose a lot of challenges in understanding transparency around how sustainable a product is.
Sorry, Olivia, to interrupt. I think your
Yeah.
slides might be stuck.
Oh,
I think yeah,
are you on system? Are you seeing system approach?
we are now. It's just changed.
Great, thank you. So we need to consider the full construction system rather than purely the substitution of a specific element. This is our belief, particularly when using bio-based materials because of their specific properties and superior properties, particularly around the breathability, the moisture, and therefore we need to be making choices around what materials are being used that are compatible and complementary to those materials. So after considering bio-based materials used in insulation wool, we need to then rethink how we fix them to make the least damage to the material. So then at the end of its life, can it be replaced or repurposed? So this therefore requires designing for disassembly, which will help with the circularity. And for example, by using screw type of fixings or clips, or not glue or cement. And the benefit of using flexible, rigid insulation is that it can then be cut to size to fit tightly within the stud wall, within the space that it's being fitted. So bio-based products also have another benefit in that they are very healthy to humans, both when installing on site and off-site construction methods. They don't require any specific PPE beyond the standard. The level of dust produced is generally less, and the particles themselves are not harmful, particularly in comparison to the petrol-derived and mineral-based insulation products, and they don't provide any allergic reactions, which is also common, particularly among the mineral-based products. So for the health and safety of the inhabitants of the building as well, during the lifetime of the product and the building, bio-based construction projects generally do not emit VOCs. Definitely not in our product's case. VOCs being volatile organic compounds, they're also known carcinogenics. These are mostly found in our paints, but to the bio-based products that also regulate the moisture flow, this allows for to stop any condensation, build-ups, and any dangerous molds from building up, which we know is a big issue, particularly in the UK when there are condensation build-ups and then mold starts to form. This can be very dangerous to the health over a long period of time, particularly to respiratory issues, currently like the one I'm suffering at the moment. So the insulation market at the moment is divided into mostly two segments, plastic insulation and mineral wool insulation. So these generally are PU or PIR, polystyrene, phenolic insulation materials. They're made out of plastic, i.e. out of oil. They are not renewable, and their manufacturing process is high energy consumption. Moreover, they're extremely fire dangerous and extremely toxic when burnt, and obviously very unrecyclable, very difficult to recycle at the end of its life. Mineral wool is highly fire safe, but it has a high embodied carbon component, and it's manufactured from non-renewable resources such as minerals. And the current low carbon building products such as hempcrete wool and cork sometimes are not as performative or as price competitive as their high carbon counterparts. Thus, there is at the moment a big gap in the market for low carbon, affordable, and performative products. Existing low carbon solutions don't provide high thermal performance and water resistance normally, and they're usually more expensive. and still have a high percentage of virgin materials. Sometimes they're only a percentage of bio-based, for example. Also, there are other mycelium competitors on the market, and often they have a high price point because of the novelty and innovative nature of the new technology. However, mycelium's natural adhesive properties make it very useful for insulation, thanks also to its lightweight nature. But I'll go into a bit more detail of that later. So just to have a look at some examples of bio-based construction projects that are already implemented in the UK. There are some really exciting projects that have been made that I will cover across different range of applications, such as commercial, public, and residential. So the first one here is a commercial building at the Adnams Brewery Distribution Centre in Suffolk, which is by Orchid Swank, built in 2006, made out of hempcrete blockwork. So it is a 0.6 hectare sedum roof, and it's supported by 41-meter long glulam beams, including an impressive 35-meter column free span. So according to the Green Suffolk website, this is the equivalent of 100 to 150 tons of CO2 locked up within the building's walls. So factoring this against the CO2 emissions during the construction of a brick and block building at the same size, this method of construction has enabled a saving of at least 450 tons of CO2. The earth-covered roof creates a meadow of grass and wildflowers, acting as a thermal buffer as well as rainwater harvesting. The roof also hosts solar collectors to heat the site's grey water and black water system, including septic tank and reed beds, enabling water to be cleaned and delivered via swales to existing ponds for use in lavatories or for vehicle washing or for irrigation, the roof, for example, in the summer. The company deliberately links economic success with environmental responsibility, and the head of finance is also the head of sustainability. So since 2008, Adnams carbon emissions have reduced by 49% per pound of revenue. So for the best example practices in public buildings, we have chosen the, there we go. We have chosen the Enterprise Centre, which is the University of East Anglia, and that was designed by Archetype. And it was dubbed at the time as the UK's greenest public building and has been designed and delivered to achieve Passive House standard and a BREEAM outstanding rating. The building is an exemplar of low carbon energy and carbon construction technologies through the use of natural and biorenewable materials, so sourced through local supply chains. So this was designed to achieve a 100-year lifespan, and the embodied carbon is 443 grams of kilograms of carbon dioxide per meter squared. And that's a 65% reduction in embodied carbon compared to a conventional higher education building at the time.
Sorry, Olivia, I think your slides just got stuck again. We can still see examples of best practices commercial buildings.
Oh, that's annoying. For me, I'm seeing the next slide, the examples of best practices of public buildings.
It looks like for me, it's sort of half loaded. There's a couple of little bits that it's sort of peeking through. That's showing it.
Are you seeing the East Anglia one now with the thatched roof? Okay, great.
Yeah, apologies everyone. We will be sending out the slides as well, so yeah, you will get to see it all.
Yeah, so so I was just saying that 70% bio-based materials by mass were used, including timber frame, thatch, lime render, and other local natural materials used, including Norfolk flint, hemp fabric, reprocessed glass, repurposed mahogany benches, reclaimed oak, clay plaster, and nettle boards. So 100% recycled sub-base was used using a unique low carbon concrete mix, and it was there was 100% recycled newspapers for the installation. And the project saw a 13% reduction in program time. So it was actually faster than the conventional methods of the time. And there was a 30% reduction in delivery time. And it was a mid-range cost when benchmarked against other university projects of a similar function. So it was at a cost of £3,500 per metre squared. 300 jobs were created or safeguarded through the use of circular approaches and by procuring low impact materials. And this was part of a core strategy to use local materials and local suppliers. So another best practice example is this, the British Science Museum, where hempcrete was also used here for a storage facility. And many of the objects from the museum are very sensitive to changing climatic conditions such as light, heat and moisture. So their objective was to create the right environment to essentially prevent any deterioration. The solution was to create a zero carbon storage building from hemp and line. And this provides temperature and humidity buffering, ensuring that the museum's collection are maintained for future generations. And the hempcrete is a material made from hemp fiber, or rather hemp shiv, the inner part of the stalk of the plant, and that lime mortar mixed with and molded in precast, pre-dried cassettes to form panels. In a similar technique, we can see here this project from Practice Architecture, which is Margent Farm, and this is our best example in a residential building. So Margent Farm was originally designed by Material Cultures, and it's principally made of a similar technique with hempcrete, processed from the actual first year's fibre crop from the farm itself, from where the house is situated. Both buildings are, the exterior walls are clad with Margent Farm's corrugated hemp fibre rain sheets. So this is utilising the fibre of the stem, where the hempcrete uses the shiv, which is the inner part of the stem. The fibre is the wool part which gets extracted from the outer part of the stalk. And then the soft fibres are thermally compressed using farm waste resins. And then the buildings are powered by sustainable biomass boilers. So I think there's also a turbine, a wind turbine, domestic wind turbine, and a subtle array of solar panels. And then Practice Architecture have now formed into Material Cultures, and are and just had the planning permission granted for their first large scale residential development in Lewes to apply similar techniques on a larger scale. We also have another best case residential project example. Excuse me. Developer here is called GS8. They are developer and contractor, and they had their own architects in-house to deliver this. So their schemes are promoting market-leading approach to first-time buyer homes, community and placemaking, and sustainability, whilst maintaining aesthetically interesting designs. And that's GS8's mission as a developer. So through a cost-saving and bio-based material approach, GS8 have used simplified construction methods to create affordable, beautiful and sustainable residential developments. I think they are open. This is in North London near Walthamstow. It's called The Arbour. And so at Mykor, we produce a product called, we produce different technologies, but the first product that we're launching into the market in the near future is called MykoFoam. And this is an internal acoustic and thermal carbon negative insulation sheet. It can actually be left exposed as well as not exposed. And it is 100% made of renewable and bio-based materials sourced from industrial waste. As I mentioned earlier, we partner with the paper industry, so we can guarantee a high level of quality and quantity as we scale up in the future. And it is 100% made out of renewable and bio-based materials. Therefore, we do aim that all of our additives are not the likes of borax. So we do create additives that increase the properties so that it's very engineered and specific to the construction industry and construction applications. However, we don't want to compromise on the sustainability. And so all of the additives are derived from waste sources. And we are using green chemistry and mycelial networks to produce highly thermally insulative, durable, waterproof, and fire retardant insulation. So our insulation panels don't emit any VOCs, and they're breathable. So they do provide a comfortable indoor environment for inhabitants, and they also regulate moisture. And our aim is to make ethically and sustainably made products more widely available in terms of supply and price. So we can reuse all of the pulp waste that's currently being incinerated. And our production plant is 75% run off solar energy. And our product is, as I mentioned before, 100% biomass, so sequestering the carbon. And that's why we say that it's completely circular, because we can actually take back the panels, and we really do encourage that whenever the product is at the end of its lifespan, that we can actually have a take-back policy. So we can then reuse those old panels to make new ones. Not only that, but if, for example, at the beginning, before the product's actually applied into the building, if a contractor or a client over orders, we can actually then take those products back rather than them going straight into the skip. And our panels are easy to install. They're compatible with other building materials, more conventional building materials. And they're being sold in standard dimensions and formats similar to those currently on the market. So this does allow for easy placement and installation into any construction project. However, at the moment, we are focusing on working in the system approach. As I mentioned earlier, we're really putting a lot of our energy and research and development into collaborations with contractors that are thinking in a like-minded way and want to create bio-based construction systems. So that we can really control the product's application, but also make sure that complementary materials are being used appropriately. So our product is developed in 2 stages. We have a lab in Bristol where our wonderful scientists are based. There's a team of 5 in the UK. And then in Portugal, where I am, we're 8. There's 8 of us, and we are essentially focused around the production, the commercial application of the know-how, the PMF, so how the product actually sits in the building from a technical perspective, and all of the operations essentially. So the factory, as you can see here on the right, is it's also taking into consideration, the location takes into consideration the fact that we're only half an hour from the supply chain, so our manufacturer, the paper manufacturer. It also takes into consideration the sun, so we're able to be solar energy fueled. And we have just started our production. So we are going to start to implement the product for the first time into building construction projects. And we are planning on focusing on the Iberian market for now, but we would really love to open a production facility in the UK in the coming years. We don't believe that in the UK we're able to deliver to the price point that that would make it feasible to be working with distributors, and therefore with Brexit it's a bit of a it's a bit complicated and a bit too pricey to be selling it. However, we will be accepting orders should a client be willing to pay that more premium price point, i.e. with transportation. But our main focus on the mass market is focusing in Portugal and Spain for now. So just to conclude, so before we finish up, I don't know how we're doing with time. I'm probably really overgone. Sorry about that. But yeah, just to conclude, decarbonising the industry is a system approach, and the use of bio-based construction is essential for the transition from linear to circular economy and in reducing the carbon footprint of the construction industry. When working with bio-based materials, we need to consider the full system and how the materials work together so that they can best function and thrive. And the choice of sustainable insulation materials is important to calculate the real carbon footprint of a building. So operational carbon, embodied carbon, and sequestering carbon. It's important to know how to read this data when specifying materials, being careful to read EPDs properly and noting what stages are actually being declared, especially when comparing. Sustainability is always a compromise, and it's about looking at the factors to consider and make context-specific decisions. Thank you very much, everyone, for listening. And if you've got any questions, I'm very happy to answer them.
I think there are a few questions just put into chat. I don't know if you want to start with those.
So I just got a lot of people upset about the slides getting stuck. Sorry about that. Did everyone get to see them in the end though? Okay, good.
I think we did, but we'll if any got missed, we will be sending them out, so you will get to have a look at them at your own leisure.
Okay. So acoustic properties, we are currently we don't have the specific. We've done in-house tests on the acoustics. However, we haven't got any of our properties data technical sheet declared from the certification perspective. We're actually undergoing that at the moment. We'll be finishing that up in August. The data is coming out in acoustic terms. It's coming out as similar to rock wool. So in terms of the insulative values, they're similar to what you would use in a stud wall. However, from an absorption perspective, it's less, you wouldn't use it as an acoustic treatment necessarily, although it can be for an aesthetic purpose. But generally, because the mycelium is so good at creating a protective layer, which is also why it's very good from a fire performance perspective, it doesn't create the surface area that is required to absorb that. So there's the two acoustic questions there, and essentially we wouldn't put ourselves as an acoustic treatment absorption product, but we would consider ourselves an acoustic insulative product. So that's the acoustic question. The lambda value is, at the moment, we are the lab scale, which is obviously a little bit kind of averaged. So we're at 0.038. We'll confirm all of these in August. And the mycelium-based networks, can you enlarge on that, please? I'm not a mycelium expert, but I'm an architect, but the mycelium essentially is the root of mushrooms. So mycelium is another word to describe the, I mean, it's its own species, firstly, so it's not a plant, it's not an animal. It's its own species, which essentially, if you've ever seen your compost, which suddenly decomposes and goes down in volume, that's essentially the mycelium breaking that down. And the mycelium is what you would, it's kind of like truffles, if you've ever had truffles. So that's what's happening with our process. I should have gone into a bit more detail there, but the process that we call is the biofabrication process is actually breaking down these biomass residues that we're receiving. And through the process of breaking it down, it creates this network, which then increases the properties of the biomass, such as the fire performance, the thermal performance, and it creates this composite that we then call the MykoFoam. We then cook it, so it doesn't have any live organisms in it. But the important part here is that when we cook it, it's only to 60 degrees Celsius. We don't require high temperatures or high energy in the process itself. But it does completely kill the living organism. So it's 100% inert, 0% humidity. And it would never reactivate. The mycelium is absolutely, once it gets killed off, it would never get reactivated again with if there's humidity applied, for example, at any stage. So it does become stable. Building is a notoriously imprecise and accident-prone process. What happens if the product gets wet, damp during construction, rainfall, plumbing outrages? Okay, this is a question that we get a lot, and it's kind of the same for I would say any bio-based construction product, and any product, whether that be rock wool or polystyrene. It's all about how you detail the building, which is also why we believe that system approach is really important in making sure that there's a high quality in the construction. But our product this is also why we develop additives. It's precisely to increase that resistance to mold, resistance to, and I would say that that's probably the biggest challenge with bio-based constructions is because of that. And hence why that's a huge focus of our lab. That's why we have a lab in Bristol is to address that issue precisely. So we have had really positive results from the development of the additives. There are tests that can prove that. We've done them and we've passed them. So we've also done actually what they call environmental chamber. So that simulates external elements such as rain, temperatures, and internal. So you have a wall where your product is placed in between the two chambers, and as time goes on, you can do it for as long as you want, but we did it for a month. You then get data on how the product is performing and whether there's being water that's being absorbed. And we did that without any, just the product itself, and just to see that really speeds it up and demonstrates the durability of the product. So that's working well. And what products are you working on using mushrooms or fungi? When will they be brought to the market? So the product is MykoFoam, and we'll be bringing them to the market in the next couple of months in Iberia, but not in the UK through distribution networks, probably for the next year, 2 years. Sorry, I think it just jumped. Okay, assume your product is similar to wood fiber. Yes, that's a good point. It is now. I think this is an outdated. No, I shouldn't say that. But the wood fiber is absolutely a comparative product to ours. We use that in our comparison normally. But I would say that the price point is similar, performance is similar. We just say that the wood fiber is obviously quite flammable, so it's got an Euroclass E, and at the moment we outperform that. So it's not soft. It's more of a rigid insulation. So more like Styco external, Pavotherm. Pavo, I can't remember which one it is now, but the ones that are more rigid essentially. And being buttered together, it does have rough edges, although it can be cut like a normal, like you would cut wood fiber essentially. So you would trim it down to the size that you need. But the edges aren't as rough as you can see in that image, because we've only got an image of the sample rather than the full size panel. So actually, the images that you saw does show quite a lot of roughness, but they aren't as rough as that in the larger panel. So how would you describe the primary differences between MykoFoam and wood? So as I said before, just the main difference would be the fire performance being better. And also we don't use borax and other additives that are actually quite ugly in terms of health in the wood fiber. And we're also not using virgin materials, we're using completely waste products, whereas wood fiber is generally using virgin trees. What accreditations and testing do you have in place for use in the UK? So in August, we will be getting, we're doing our certification process in Portugal. Obviously being in the EU, we'll be getting CE marking. And that until June 25, apparently, is automatically convertible into UKCA. So we should have that in around September. I don't know how long the process is in converting that, but I've been told it's relatively straightforward, simple, because of this new legislation that got extended until June 25. BBA certificates, we're not doing BBA agreement. That's not in our timeline in the near future. BS standards, yes, they're all of the European standards have got a relative BS1 British standard, and they will all be rectified when we do the UKCA recognition. Fire testing will be the same, but they're all going to be done in the Portuguese lab. And NHBC, I don't know what that is. Does somebody mind explaining to me what that is? Because that would be interesting to know. I can just make a note of it anyway and Google it. Have you carried out thermal bypass tests and WFI? That's actually the environmental chamber that I was talking about, and not in conjunction with other materials though, although that's something that could be done. And we've got an ongoing collaboration with the University of Bath and a few different grants that support the costs of all of that co-development with them. So that is something that we'll be doing over the next year or so. We've got different demo projects where we'll be measuring that in situ as well. Is it possible to eat? No, no. Is it edible to? Wait, I'm not sure whether that's a real question. No, it's not edible. You can't eat them. But oh, National House Building Council. Okay, thank you. And fire class B, that's what we're aiming for. Yes, that's what our in-house testing has been indicating until now. Obviously, we still need to get all the data third-party verified. And the image again, which image would you like to see, Sandy? I
just thought you might have shown a sheet of it, and we
the sheet. Yeah, I can try and find.
The image has got.
I can try and find a better image. Yeah,
who knows what we missed?
No, you're right, because this is a CPD that we had certified, so it's a little bit not outdated, but it's just it was a certified one, so we're trying to stick to that in case you do want your CPD certificate. But the panels, I can just get a picture of the panel of how they're looking at the moment. Bit of inside information. This is live from the factory at the moment. got it on my phone. I'm just trying to find out how I get it up on my computer. Anyway, I can send it. Why don't I send it through afterwards when I send the slides, and you can have a look. Because then you can get an idea of the edges, because that was a question that came up, was whether it's a really rough edge, and you can see in the image that it's really quite smooth actually, when it's at a larger scale. Because the image that I had up was a sample of that size, so the edges look a lot rougher than they actually are at real scale.
You said that you can make it in standard sizes for,
Yeah,
but what kind of, like, what's the biggest size that you've
at the moment
with?
we're doing 600 millimeters by 1,200 millimeters.
And then what thicknesses does it go to?
And then at the moment we're doing maximum of 100, and we're also doing 100 millimeters and 50 millimeters. Those are the two thicknesses that we're doing. In the future, it's possible we'll be able to go thicker and also thinner, but at the moment those are the two thicknesses that we're working with.
And would it work that you could put to make 200, you could use two?
Yeah. In fact, it would probably be better. It would probably be better to do that like in the same way that wood fiber is done, because you can then layer it up, and it helps with thermal bridging, so that you don't just have like two joints where you have potential thermal bridging there so when they overlap, you're exactly. Yeah. Yeah.
I've got more of a picture in my mind now of what the thing is.
Yeah, and I think next time, obviously we've still at an early stage, so we'll be putting images on our website about when we have those when the product is actually installed in projects. You'll be able to visualize that a bit better. The moment it's just drawings, so yeah. But it's, if you just think of a wood fiber, it's just exactly very similar to that. Yeah. Oh, real question. Is it edible to fungus? Oh, I see. I thought you meant, is it edible itself? Honestly, I'm not a biologist. I really don't know. It's not in terms of those specific species, I've got no idea. But what I can say is that we get questions about like rodents and whether whether animals or something can eat it. And honestly, I think it's a similar answer to any other product, really. It depends on how it's detailed, and it's also not really something that we can test, so it's not something that I can really respond to now. But as I say, the additives that we're developing have proven that in the mold tests we don't get mold. But other than rodents, yeah, it's hard to say, really.
I can say that I saw a bin.
Yeah.
Bin we put our things in, and it had rats that had eaten through it, and I did not comprehend what it was until someone said, "It's a rat that's done that."
That's the thing. It's like
unbelievable what they can chew through.
It's like a rat can eat through plastic and probably even metal.
Yeah.
It doesn't, from my perspective, it doesn't matter so much about what the material is made out of. I mean, it could even eat wood probably, and you wouldn't not use wood because you're worried about the rodents eating it. But I think that it depends on how the building is detailed, and that it comes back to quality, really, of the execution of it.
Don't can grow in it that a rat will want to get to.
Exactly. And I mean, the product, when it's with the mycelium, that was what I was also referring to about the absorption. So when we've got absorption so with the acoustics question, the reason that mycelium is not as performative from an absorption acoustically, from an absorption perspective, is because the mycelium network just creates such a strong bond, and actually that bond, I don't know, like for example, with hempcrete or with walls, like you have a much better acoustic performance probably, but there's more access inside the product, whereas the mycelium creates this kind of binding.
They're closed. Well, they're closed cell.
Exactly. Yeah. Yeah.
Yeah. Excellent. I'm sure there's a great future for it.
So what are the, sorry, I just realized there are more questions. Do you have any scaling up issues? There's always issue. I mean, this is less, I would say less from a practical, technical perspective, more from like business perspective, I'd say, which is obviously this has not been done before. It's a new process. There's contamination issues. So there's a whole load of scalability issues around on how one designs new machinery to do that. But that's part of our R&D. We're very much manufacturing as well as product developers. So we're focusing on the process as well. And then that would be a question of raising sufficient funds to be able to implement that at scale. And so those would be the main issues that I would see. And making sure that we design the right process so that we do eliminate the main issues around production, which is essentially contamination. And contamination being when you are trying to grow one species and then suddenly you get a mold that will come and take over, and then it will just go moldy. So also another thing to add is that with mycelium, if the mycelium has fully cultivated, it means there would never be any mold, which is also a good sign. You know that if mycelium is present, you're never going to get mold because it's essentially colonized all of the biomass. And what else was I going to say? Any issues? No, I would say that we're working mostly with, as I said before, we're working mostly with contractors that we can partner with, so that we can scale up on a system level. And I don't know, what is the EWI system? Is that a
external wall in?
Okay, so external wall, yes, like an ITIX. Is that what you mean? Like an ITIX system? Anyway, that's something that we're working on at the moment, analytics. And how does your product differ from the mycelium composites from Ecovative? So Ecovative are a US company that have patented and then open sourced the use of mycelium in a mold, so a form that the mycelium then grows into, and it creates that final shape because of that mold. So what they did is they patented that. Where we differ is that, well, first of all, Ecovative aren't in Europe, and they have a subsidiary in called Grown Bio in the Netherlands, but they aren't producing for construction specifically with the intention of scaling up to enter the mass market of insulation. And they don't have the knowledge on how we make them. That because Ecovative are so broad, they're not focusing on one specific industry. I don't really know what Ecovative are doing. I don't really care either. But what they're doing is they don't develop it specifically for construction, which is what we do. So we're really focused on construction and making sure that these are products that are that are genuinely usable for construction, and that means additives, and that means really engineering it to be used in that way. So yeah, Ecovative aren't really focusing their energies on that. They're mostly focusing on packaging, to be honest. So yeah. And also in terms of the actual, I mean, it's all about when it's about the composite, when you're asking about the actual composite itself, it's much more about utilizing. I mean, I think for them, they're utilizing hemp. They're also utilizing, I'm not really sure, to be honest, but from what I understand, they're not, but we're mostly focusing on waste sources, whereas hemp is obviously it's an arable crop, so it's also a virgin material, and they buy it, whereas we are almost getting paid to get rid of a waste product. So yeah, there's two things really that stand out from our competitors in general. External resilience. Okay. What was the question specifically? Are you asking whether we've done tests on the freeze thaw?
Yeah, I think it was more just pertaining to the EWI systems, maybe a bit of a misleading question, but it was more sort of like, can it be used externally in the way that you would use, like, say, rendered wood fiber or something along those lines?
You would, so at the moment we're not certifying it for this use yet, but we will be doing it in the future. So I don't really know how to answer at the moment, but
in development.
It's in development, but we know that it's possible. But yeah.
Cheers.
Thank you.
I think that's the last of the questions, and we've hit 6 o'clock.
Yeah.
So I think we'll close it there. I just want to say a huge thank you to Olivia today for coming and presenting, and thank you so much for everyone for coming along and asking questions and being really involved. That's always, we really love that with our Twilight talks and all our events, really, just seeing that interaction. So thank you to everybody on the call at the moment. And yes, as I said earlier, we will be sending out a feedback form. Please do fill it out, and we'll be sending out the slides and a copy of the video as well and the chat transcript to everyone who's signed up today. If you're not already a member, please do consider joining the Green Register to see more of our training, and members do get a discount on it. And check out greenregister.org.uk for all our upcoming events. Feel free to sign up to our mailing list to be notified about them. But other than that, thank you all for your time. Enjoy the rest of your evening, and we hope to see you at something soon. Thank you, everyone.
Thank you. Bye-bye.